Hello everyone, my name is Marcus Kander. I'll be explaining today how to solve rotational motion questions that involve calculating velocity for vertically spinning objects. For this question, you're asked to calculate the minimum and maximum velocity of a 0.48 kilogram yo-yo attached to a 1.5 meter string. You're told that the spring can only support 48 newtons of force. The first step to solving this question is to draw a free body diagram. I'm going to draw two of them for you. One when the yo-yo is at the top of the circular path, and one when the yo-yo is at the bottom. Minimum velocity will occur when the yo-yo is at the top of the circular path. To understand how this happens, let's examine the forces acting on the yo-yo. At the top, there are two forces contributing to the centripetal force, Fc. First, there is Fg, force of gravity, which acts straight downwards. Second, there is tension, which acts inwards toward the center of the circle. This is represented in the following equation. Technically, the yo-yo does not need tension in order to go from the top of the circular path to the bottom. It only needs Fg to do that. For this reason, minimum velocity will occur at the top. Since tension isn't needed, we can set c equals 0. We know that Fc is equal to mv squared divided by r, and Fg is equal to mg. So go ahead and plug those into your equation. Next, rearrange the equation for velocity by multiplying both sides by the radius, cancelling out the mass, and square rooting your equation. Your final equation should be the square root of gr. Now all you have to do is plug in the missing values, which should give you v equal 3.84 meters per second. Now that we're done with minimum velocity, let's analyze maximum velocity. Maximum velocity will occur when the yo-yo is at the bottom of the circular path. At the bottom, there are two forces contributing to the centripetal force, Fc. First, there is Fg, the force of gravity, which acts straight downwards. Second, there is tension, which acts inwards toward the center of the circle. When drawing the free body diagram, make sure tension is greater than Fg, because if they were both equal, that means the yo-yo will not move. Tension needs to be greater to show that the yo-yo will in fact move upwards along the circular path. This is represented in the following equation. We know that Fc is equal to mv squared divided by r, and Fg is equal to mg. So go ahead and plug those into your equation. Next, rearrange the equation for v by multiplying both sides by the radius, dividing out the mass, and square rooting your equation. When calculating for maximum velocity, there isn't much that you can cancel. You need to account for tension though, in your equation, because the string will snap if you exceed the maximum allowed tension. Your final equation should be the square root of r multiplied by t minus mg divided by m. Now, all you have to do is plug in the missing values, which should give you v equal 11.6 meters per second. That's it for this video. Thank you so much for watching. If you have any questions or want me to clarify anything, please leave me a message in the comments and I'll respond to you as soon as possible.